As we look at more specific parallelograms, we come to a rhombus, rectangle, and a square. And the way this works is all of these shapes we look at in this video are parallelograms. But a rhombus, rectangle, and eventually a square are special types of parallelograms. All of the rules that apply to a parallelogram, which was the previous video, still work here, but these are specific rules that go to these shapes. So let's go to a rectangle first. We're kind of going to throw all these properties out there and start to work through and solve. So we should know that a rectangle is a parallelogram with four congruent angles, or four right angles, because if they're all congruent, they all need to be 90 degrees. So that is the definition of what makes a rectangle. We also get the rule that diagonals are congruent. So not only do they bisect each other because they are a parallelogram, but the diagonals are congruent, the total length of them. So AC and BD would be congruent. What this also gives, which kind of helps later as we solve for a rectangle, is it gives us two sets of isosceles triangles. So like these left and right triangle and the top and bottom triangle are isosceles triangles that are congruent. Now not all four of them are congruent, but it's going to help as we solve for angles, and we'll see that in a minute. Now a rhombus is a parallelogram with four congruent sides. So rectangle has the congruent angles, rhombus has the congruent sides. It may look like this, or we typically see it as this. Don't call it a diamond. Some students will want to call it a diamond, and it's not a diamond shape. We don't have an official diamond shape. We call that a rhombus. Other rules that we have are diagonals are perpendicular, so they meet and form right angles, as well as the diagonals bisect opposite angles. And this is why when we talk about parallelograms, we want to make sure we say that the diagonals bisect each other, because they can also bisect opposite angles, as they do here. Now what we start to see, if I throw in the right angles because of the perpendicular, is that a rhombus actually gives you four congruent right triangles. So rectangle has some isosceles pairs. The rhombus gives you four congruent right triangles. Now, not necessarily isosceles right triangles, but we can kind of start to see with reflections and rotating things around, all four of these triangles match, which will help us with what we're going to look at. Last is a square. Now, a square, by definition, is a parallelogram with four congruent sides and four congruent angles. It does not have any unique properties separate from a rectangle or a rhombus. It has all of the properties of a parallelogram, a rectangle, and a rhombus. It just needs to be both qualifying as a rectangle and a rhombus. It has to have both parts of each. So we have to be careful when we're classifying something as a square to make sure it meets both conditions of rectangle and a rhombus. So let's go through and just start to solve for some different parts. So DB is 42 and AD is 26. So it's 26 and 42. Now we're going to have to go through and solve for some parts. So if DB is 42 and we need to find AC, which is a diagonal, we automatically know that is also 42. In fact, because it's a parallelogram as well, we could say that diagonals bisect each other, so EB is going to be 21. BC is going to be an opposite side to AD, so that will be 26. And the last part we have to find is AB. Now this one, I'm going to draw, I have AB and D. We go 42 and 26. If we need to find what AB is, we have to actually use Pythagorean Theorem. We have a right triangle at A, or a right angle at A because it is a rectangle, and we know the hypotenuse and a leg. So it's going to be 42 squared equals 26 squared plus AB squared. Now 42 squared is 1,764. 26 squared is 676. We're going to subtract that. Gives us 1,088 equals AB squared. And I'm just going to round to the nearest whole number here because we have the square root of 1,088. So we're going to say that AB is about approximately 32.98. So we're going to say it's about 33.0. Now, Pythagorean Theorem is not the main focus for what we have, but we do have to be ready for when those types of problems come up. So that takes care of our sides. Let's go in and look at angles. Now the only thing they gave us for angles is DAE, which seems odd that we can find all of these other parts, but let's go through looking what we know. Now first off, angle A is a right angle. So if 52 is the angle, the complement to it would be 38. We also said earlier that these form little isosceles triangles. So if this 52 is there, I also have a 52 at D and a 38 at B. But these isosceles triangles, or the left and right ones, are congruent. So we could go 52, 52, as well as top and bottom give us 38 and 38. Now all of that with the assumption that the A, B, C, and D themselves are 90 degrees. Once we have that, we can find the third angle of each triangle, which all happen to meet in the middle, where we have linear pairs and vertical angles. So we have 104 and 76 all the way around. So really, by that one angle, we can find all of them in a rectangle. Now let's go back and find which parts they want. So ADC is just 90 degrees. ABD is going to be 38 degrees. BCA is 52 degrees. And DEC is 104 degrees. So it seems like overkill that we found all of those values, but it's important we won't make mistakes. Everything will match. It'll check out whenever we do need to solve it that way, so we can find all of our angles. Now we go to the next one. We have a rhombus. So ZY is 34. WY is 38. So instead of writing 38, I'm going to split it. It's 19 and 19. Maybe that'll help me. ZXY, it's an angle. We'll get to that. So let's first look at the sides. So WZ is 34 also, because it's a rhombus. All sides are congruent. VY is 19. That's the one we split. ZV, we got to find ZV. Well, we know the diagonals are perpendicular. So this is going to, again, give us a right triangle. So ZV, 19 and 34. So again, we're going to go Pythagorean Theorem. 34 squared equals 19 squared plus ZV squared. 34 squared is 1,156. 19 squared is 361. If we subtract, we get 795 equals ZV squared, and the square root of 795 comes out to be about 28.2. So that's ZV, but then when we want to find ZX, because the diagonals bisect each other, we can just take that and multiply it by 2, and we get about 56.4. Now, that's the sides. Let's go to the angles. I know I have right angles at the intersection, so let's throw some right angles in there. Then we know that ZXY is 34 degrees. Now we said that the diagonals bisect angles earlier, so we could make both of those 34, as well as go to Z and make both of those angles 34, because not only are opposite angles congruent, but they are also bisected. Now I have right triangles with a 90 degree and a 34. 90 minus 34 gives me my third angle of 56, which is the angle measure of all the remaining parts. So let's go find the values we want. WXZ is going to be 34 degrees. WVX, or WVZ, is 90. ZYW is 56. And XYW is 56 as well. Okay, now we have a square with side length of 11. We need to find each value. So we know all sides are congruent, so that is 11 for BC. If I drew a triangle with 11 and 11, and I wanted to find the hypotenuse, which is really AC as well as BD, because diagonals are congruent. That's going to be 11 squared plus 11 squared equals x squared, or 121 plus 121 equals x squared. 242 equals x squared. So x comes out to be two options. We can either write this as 11 root 2 or about 15.6. Now, later on, we see more of dealing with radicals and simplifying them, and even a special type of triangle from this. So for right now, let's just write 15.6 and call it an approximate by rounding, and we'll be good there. EC would be half of that, which would be about 7.8. Now we need to find angles. So I know they're all right angles. I know diagonals intersect to be right angles, and since they bisect, all of the other angles around here would also be 45s. So really our only options are 45 and 90 as we look through. So DAB is a 90-degree angle. AEB is a 90-degree angle. CBD is going to be 45 degrees. And BAC is also 45 degrees. Next, we have a rhombus. We need to find angle FED, which is this angle here. Now, I know the two expressions that I have are equivalent because the diagonals bisect the angles. So I'm going to set those equal to each other. Once I find what x is, I can substitute back in and find what the total at F is, and then I could then find FED. So we get 3x equals 21, so x is 7. Now, I'm going to be able to double it, whatever I get, so let's just go 5 times 7 plus 1, which is 36, so that makes this angle 72. So the measure of angle FED is going to be 180 minus 72, or 108. Now we have in our next one a rhombus, and we need to find some angles. So I know that angle 3 is also 38, angle 4 is 38, and angle 5 is 38. That's because opposite angles are congruent and they're bisected. I know that 8 is 90 degrees because the diagonals are perpendicular. I also know that 1, 2, 6, and 7 are all going to be the same value. We just need to do 90 and 38 being two angles of the triangle to find the third. So 90 plus 38 subtracted from 180 leaves us with 52, and that would be all of the remaining angles. For bottom left, we need to find the measure of angle BCE, which is this one. Now I know the two angles that I have expressions for are equivalent because they're alternate interior angles, and then I know that the 11x minus 3 is a complement, or it's complementary to BCE, so I could subtract it from 90 once I find those. So let's go 7x plus 5 equals 11x minus 3. We get 4x equals 8, and x equals 2. If I substitute that in, we get 22 minus 3, or 19. Now, to find the measure of angle BCE, we're going to do 90 minus 19, and we get 71 degrees. Last one, we know RT and US, which are our diagonals. We need to find VT, which is going to be half a diagonal. So diagonals are congruent. 5x minus 14 equals 2x plus 10. We get 3x equals 24, and x equals 8. So to substitute back into RT, 5 times 8 minus 14 gives us 26, so then VT would have to be half of that, so it is 13.